So if you guys are looking at, sorry, that's shaking a little bit. If I had negative x squared plus 5, can anybody tell me what the vertex would be just from looking at the equation there? 0, 5. Okay, 0, 5. Now, so I'm just going to go ahead and come over here and plot that point. Here's 0, 5 on the graph. Now, once you have that, you need, if you can find the pattern, which I'm going to write down here in a second, that and the vertex are the only two things you need to graph and make graph with multiple points without having to make a table. Does anybody remember, not for this graph, but just in general, what was the pattern that we were using for a quadratic graph? Do you guys remember from Monday? What was it? Yes, 1, 3, 5. And if you guys don't remember, like if I write, I'm just going to write a couple of these so you guys can see them. So if I write down like 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. The deal is between these numbers, like I'm adding 1, I'm adding 3, I'm adding 5, I'm adding 7. If you continue writing perfect squares, which is what you get when you square something, we're using quadratics here, they're x squares, that goes up by odd numbers. I just used the first 3 numbers in that to write the pattern to help see the relationship there. But if your a value is not 1, my a value here is negative 1, all you do to write the pattern for the graph that you're trying to look at, take that a value and just think about it like distributing it to the 1, 3, 5. So what that's going to do for this graph, it would just be negative 1, negative 3, negative 5. And I can just use that pattern to help me get more points on this graph. So it always works the same way. Don't have to write this down. But you're going to go over 1 on either side of that vertex and then up or down the pattern. In this case, the pattern is negative 1, negative 3, negative 5. So I would go down 1. The next step you would go over 1 and then down 3, and then I'd go over 1, down 5. So on either side of that, just over 1, down 1. And then from those 2 points that you put on there, over 1, down 3. And then from those 2 points, over 1, down 5. And then I'm just going to do my best to make a U shape. So it's curved there. And that's got 7 different points that we graphed using that pattern. The minimum number you want to graph is 5 points, but if you can get more than that on there, try to do it, because the more points you have, the more accurate your graph is going to be. Now, no matter what, any parabola you graph, this one's turned upside down. This is going to the left forever. Even though it's going down, it's also going to the right gradually forever. Every single parabola that you would graph has the same domain. They should all go from negative infinity to infinity. The range is going to be different, and you're going to have to look at the graph to determine that. So whenever you do an interval, you always start with the lowest possible value. So for my y values, what's the lowest possible value? Negative infinity, right? What is the last point that I touch? What is the biggest possible y value? 5. And the range always is going to have a bracket around the number, because you actually, that's going to be the vertex of the graph, but you actually touch that point, so it'll have a bracket on it because that point's going to be filled in there. But that's all you have to do. Okay, now if I slide over and look at this one, I've got 2x squared minus 5. Does anybody know what the vertex for that other example would be? I feel like somebody just said it. Yes, 0, negative 5. This negative 5 is what's going to shift the y coordinate to be down 5. If you just have an x squared by itself, I don't have any plain x here, we'll deal with that later in the week. But if you just have a plain x squared and then minus or plus a number, x is going to be 0, and then the y is just going to be to copy that plain number. Now, the pattern here, your a values, whatever's in front of x squared, that'll affect your pattern. So this is going to be 2. So if you have something other than 1, just go ahead and multiply that by the 1, 3, 5. And that'll give you the pattern for the graph you're looking at. So 2 times 1 would be 2, 2 times 3 is 6, and 2 times 5 is 10. So we won't be able to get all the pieces of that pattern on this graph, but we can at least get the first 2 steps. Once you have those two pieces, you can graph just 0, -5. That's going to be my vertex. Now, the way this one works differently, it's always over 1 on either side of the vertex, but what we're going to do is go up 2 instead of what we did on the last one where we went down 1. So just on either side, over 1, but go up 2. This is going to be more narrow than what we just graphed. And then I would go over 1, up 6. And that should put you, let's see, should be on 2, 3, and -2, 3. And again, just do your best to make a U shape. It doesn't have to be perfect. But this is going to be a little bit more narrow than the graph we just did. The 2 is going to make this a stretch. We're going to talk about that more in a second. Domain, no matter what, goes left and right forever. It looks like it points up, but one side points to the left. This is your left, and one side points to the right. The range, what is the lowest possible y value on this graph? The -5. So this looks different in terms of the range than the one we just did. So this one I'm going to start with the y-coordinate of the vertex. Then everything else goes up forever. We're going to go cover all the y values above that. So that's going to be -5 to +infinity. Does anybody have any questions? All right. Now, we're going to shift some of these graphs today. So we're going to use the vertex form. The standard form is another way you can graph, but we're not going to do that today. We're just going to do vertex form. So that looks like this. Y equals, you're just going to have an A, and that's going to affect your pattern. And in parentheses, x minus h, and I'm going to close the parentheses, and that set of parentheses will be squared. And then outside the parentheses, I'm going to put a k. This works exactly like absolute value graphs. The HK is going to be the vertex. This time, though, instead of being for the absolute value, it's going to be for the parabola. Now, this works also like the absolute value inside with the x in the operation. Instead of being an absolute value, it's a squared here. So inside the operation, it's going to be the opposite of what it looks like. And then whatever the value is added or subtracted, that's going to be what you want to copy. So h is going to affect the x-coordinate of the vertex, k is going to affect the y-coordinate of the vertex. Once you have that, you can just use the a value, which we'll be able to see from the formula, and then find the pattern, and you'll be good. So, come down here. So my first example, before I start this, can anybody tell me, I've got x minus 2 squared and then -3. Does anybody know what the a value is? 1. Okay, good. I had somebody this morning say 0. You got to be careful though. If it was 0, it would wipe that whole set of parentheses out because you'd be multiplying by 0. So if it exists, it has to be a 1. Typically, you're not going to see a 1 written in front of that, but that'll also tell me immediately what the pattern is, which is just a plain 1, 3, 5. Can anybody tell me from looking at the equation what the vertex should be? 2, -3, opposite, so it looks like the opposite. This looks like a -2 to me, so it's +2. It's what actually sets the set of parentheses equal to 0. That's where it switches from one side of the U to the other, just like it does with an absolute value graph. Those are the only two things you need to get a bunch of points on here. So just find the point over 2, down 3. And then for my 1, 3, 5 pattern, from that vertex, on either side, just go over 1, up 1. From both of those guys, just go over 1, up 3. And then this will fit on here, go over 1, up 5. And just do your best to make a U shape. If you're asked for the domain, automatically, if you're graphing a parabola, the domain should just be -infinity to infinity. It's going to go left and right forever. It goes up really fast for this question, but it does go and cover the whole x-axis, gradually to the left, gradually to the right forever. For my range, what's the first y value I would actually touch on this graph? -3. And we're just going to use a bracket, and then the rest of it to infinity, so and beyond. So it goes up forever, so it's going up to infinity. All right, now, the one right next to this. See how there's just a little subtraction sign out in front? That means your a value is -1. For the pattern, all that's going to do, it's just going to make it -1, -3, -5. What would the vertex be for this second quadratic I have for would the vertex be? What was that? And yeah, okay. I thought you said -6, so I was just being careful. Okay, so opposite, this would be -4, and then copy this one on the outside. So it's going to be -4, +6. So just find that point, go -4 and up 6. Because my pattern's negative, that just means my graph's going to turn upside down. So just over 1, down 1 on either side, over 1, down 3. And then this will fit here. I'm going to go over 1, down 5. Okay, count it. All right, there we go. All right, now domain, no matter what, even though it's pointed down, it is still gradually going to the left forever and to the right forever. So you would cover the whole x-axis. The range here is what you got to pay attention to. That'll be different for each of these graphs. So what is my lowest possible y value for this last graph here? -infinity. So it's going to the bottom. And then I get stopped at the top, which should just be the y-coordinate of the vertex, which is 6 here. A little bracket on it. Does anybody have any questions? Sweet. All right, now, all I put together here is a little, just like everything you can get, just if you have the vertex form, like what can I get from the equation just by looking at it, and you can get all this information. So I'm just going to fill these in real quick. The vertex is going to be your HK. Now, if it asks you for a maximum or minimum value, it's only one or the other. If it's a maximum value, the graph would turn upside down. The vertex is going to be at the top. If it's a minimum value, the parabola would turn right side up, be a right side up U shape. So it's one or the other, not both. But it's just the y-coordinate of the vertex, which will be k in that formula. If you have an axis of symmetry, if it asks you about that, I'm just going to draw a little parabola over here real quick. So axis of symmetry, if you guys remember, it's just a vertical line that splits the parabola exactly in half. So if I were to fold it on that line, the two sides would match up. It has to go through the vertex. So it's always a vertical line. I call it vertexal to help me remember it. It should just be x equals a number. And then in this case, if you have it in vertex form, your equation should be the x-coordinate of the vertex. So that would be h from that formula. All right, horizontal translation, if there is one, that's going to shift your graph left or right. That's a horizontal one. That's going to be affected by whatever h is. Your vertical translation is going to move your graph up or down, and that's just going to be whatever k is. And I'm going to make a tiny little note to the side before we talk about stretch or shrink. So if your a value is 1 or -1, you have no stretch or shrink. That would just be considered like a normal version of a quadratic, because it would just be a plain x squared or a plain -x squared if you actually had an equation. So if you're actually equal to 1 or -1, you don't have a stretch or a shrink. If there's an a value other than 1 or -1, then you're either going to have a stretch or a shrink. And what I put out in front here, ignore whether it's positive or negative. That's just going to tell you if the graph goes up, if it's positive, if it's negative, it flips it down. If the a value is bigger than 1, you'll end up with a graph that's a stretch. And that's going to be kind of like a more narrow U shape. If you've got an a value between 0 and 1, so that means like a half or 2/3 or something like that, that's vertical shrink. If you have a shrink, it's going to be a wider U shape on your graph than what we were doing on the front. No matter what, your domain for any parabola is -infinity to infinity. I'm going to write two things for the range because that depends on how it turns. If your graph turns right side up, your range would start with a bracket and the y-coordinate of the vertex, which is k from that formula, so it would be k to infinity. If your graph turns upside down, then your interval for your range starts with -infinity and it stops at the vertex, so it's written in a different way. So it just depends, but every time, if you know the y-coordinate of the vertex, the range would fit into one of those categories depending on how the graph turned. Does anybody have a question at the moment? So what we're going to do in example 2 is we're going to do just an analysis of this graph. So it's going to ask you a bunch of questions, and we're going to put this graph on the grid here. I have y equals 2, and then x plus 1 squared minus 6. Can anybody tell me, just looking at the equation, what should the vertex be? If I do my opposite copy thing, what would it be? What do you think? -1, -6. Definitely. Okay, now the pattern here, your a value is 2, so you don't have to write all this out if you're comfortable with it, but that can affect, or it does affect the pattern that we used. So I got to multiply my pattern by 2, so that would be 2, 6, 10 there. Once you have that, you have everything you need to graph. Just put the vertex, go over 1, down 6, and then from there I'm going to use my pattern. So over 1 every time, but my pattern is up 2, and then over 1 every time. I'm going to go up 6. Over 1 up 10 is not going to fit on this particular window that's provided for you guys here on the note paper. So that's 5 points though. That's plenty of points to write our parabola. Now, axis of symmetry, you don't have to draw it in, but I'm going to draw it in on my paper here real quick. So it goes right through the middle, has to go through the vertex. So it's a vertical line. It should just be x equals the x coordinate of the vertex. So for this graph, it's going to be x equals -1. Now, would the value on this graph, if you're looking at it, would it have a maximum value or a minimum value? Minimum, right? Because the vertex is at the bottom. So I'm just going to circle the minimum. I just abbreviated that. The actual value, all you have to do is write down the y coordinate of the vertex, which should just be the -6. Domain for every single one of these, -infinity to infinity, and the range is going to start at the -6 and then go up forever. In terms of horizontal translation, that's just how the graph from the origin would move left or right. So this is going to be based on the vertex. So this is going to be with the x coordinate of the vertex. So it's just going left 1, and then we went down 6. So I'm just kind of describing the vertex. So vertex is -1, -6. So we're going left 1. That's the first number in the point. The second number in the point is what you do up or down. It's -6, so we're going to go down 6. And this is a stretch, because you can just circle it. You don't have to write it. That a value is 2. All right. And we're going to do one more. Now, immediately on this one, I see, and I would recommend this to you, my a value is -1/2, just whatever's in front of the parentheses. And I'm pretty sure I told you guys this the other day, but I always recommend, if it's a fraction, I tell people to actually write it as a decimal when they multiply it by the 135 pattern, because people will accidentally use the fraction like they use a slope. So they'll go over 2, down 1, or whatever. It doesn't work that way if you do it. And if it's a decimal, we're just going to have to estimate. So this is going to be, oops, sorry, it's negative, my fault. -0.5, -1.5, and -2.5 for your pattern. So we're going to go down here. I totally forgot to write the vertex. What would the vertex be here for this graph? 3, 7. All right, so there's where we're going to start. 3 to the right, up 7. And what I might do is just come down and write that right here for my horizontal translation. I went right 3, and I went up 7. This is a shrink. This is going to be wider than the graphs that we've had so far today. And when you use the pattern here, it doesn't have to be perfect. If it's a decimal, just do your best to estimate. So on either side, I'm going to go over 1 and down 1/2. So I'm just going to go on the halfway mark. And then the next set of points should be nice. So I'm on the halfway mark. I'm going to go directly over 1, and then I'm going to go down 1 1/2. That should put you on the point 1, 5, and on the other side, over 1, down 1 1/2 would put you on 5, 5. So those are on nice points. And then I'm just going to go ahead and do one more step in that pattern. Over 1, down 2 1/2. So just kind of estimate. It doesn't have to be perfect. Over 1, down 1, 2 1/2. Just do your best to go kind of halfway between the grid marks if you're trying to estimate that. Now, axis of symmetry goes right through the middle there. So it should just be x equals x coordinate of the vertex, which is 3. Does this graph have a maximum or minimum? Maximum, because the vertex right at the top, there's nothing above that. This is a maximum. The actual value, you just grab the y-coordinate of the point, which is 7 for this question. And then I just got to fill in the domain range real quick, and then we'll be done. So no matter what, negative infinity to infinity, you're going left and right forever, even though it's turned upside down. Your range, you want to make sure, start your range with the lowest possible value. Since this point's down forever, it's going to be negative infinity. And if I was kind of rolling my pen through this graph, I would stop touching the graph at the y value of 7. There's no more of that parabola above there, so that would stop at 7, and you're going to have a bracket. The last point it touches is the vertex. It's an actual point on the graph, which is why you have a bracket. Is anybody having a question?